Welcome, Plasticity Fellows, to another thrilling episode of Plasticity for Noobs. Here we ensure that even beginners can delve into the captivating world of plasticity. In today's video, we're going to plunge headfirst into some advanced lofting techniques. I'll be sharing some expert lofting tricks that will assist you in creating a mesmerizing crane hook. Building a crane hook requires 8 points of tangency to achieve the desired outcome. This may seem a bit technical and more challenging compared to the previous shape studies, but fret not. I'll guide you through it in a way that anyone can follow. Don't make the mistake of assuming that the frame hook is a simple shape to study. It's not. Stay tuned to find out the correct way to approach it. So fasten your seatbelts and prepare to acquire some mind-blowing techniques that will elevate your plasticity skills to new heights. Let's dive right in. Oh, just a quick tip for you. Down below in the description, you'll find all the timestamps to easily switch between different chapters. I have already created the construction curves in real scale. This means that the size of the 3D model matches that of the real-world crane hook. Additionally, I have included all the measurements to clearly show the size of each individual curve and circle. To make it easier for you to reference, I will keep the existing construction on the right-hand side so that you can see the measurements whenever you need them. As you can see, there are circles of various dimensions. Take this one, for example, which measures 9 centimeters, and this one, which measures 4.5 centimeters. Additionally, there are some lines that I made to define these circles and the one next to it. All of these lines and circles are hiding the shape of the crane hook. In order to move forward and define the shape we need, we simply have to split the curves at their points of tangency. As mentioned earlier, we have 8 points of tangency if I can recall well. Now, let's dive into the construction of the curves and learn how to do it. Let's break down the process step by step. To start, create a circle at the top with a diameter of 9 centimeters. We'll be utilizing the circle tool and line tool. To ensure precision, make sure the grid snap feature is enabled. You can find it at the top right corner of the screen. If you're unable to locate the menu on the right, simply press Ctrl+B to access it. Alternatively, you can left-click on the button located at the top left corner. Let's get started. To adjust the size of the circle, follow these simple steps. 1. Left-click and drag in the viewport. 2. Press the Tab key to activate the input field. 3. A pop-up will appear where you can enter the desired measurement. For example, type 9 centimeters. 4. Right-click to confirm the changes. Now, we want the inner circle to be half the size of the outer circle. To achieve this, we need to repeat the steps, but this time, type in 4.5 centimeters as the diameter. Now let's establish the 2 lines that will enable us to proceed. Grab the line tool and create 2 perpendicular lines, each measuring 18 centimeters. If the second line doesn't snap on the curve, like in this case, simply create a line starting from the center of the circle. Then you can unjoin it and delete the smaller line. In this case, you have 2 options. You can either keep the grid snap feature on to ensure the point snaps correctly, or you can hold down the Control key, click, and drag the point along the Z-axis while hovering over the desired alignment point. As mentioned earlier, disconnect the 2 parts and remove the smaller one. Next, let's move on to creating the 2 circles below, with their centers located on these points. Remember that this circle has the same size as the one above, just 9 centimeters. The larger circle has a diameter that is equal to the length of the perpendicular line, which measures 18 centimeters. Now take the line on the right and make it the center of the circle. Just click on this point and drag, Then press Tab and enter the measure in the input field. Every now and then, I'll go over the most fundamental tasks as a reminder. Next, let's create a diagonal line. Take a look at this line. It has 2 points of tangency. One is up here and the other is down here. I chose to provide you with this example of the crane hook because, despite its simplicity, it serves as a perfect case study to delve deeper into the concept of tangency. These 2 points of tangency are crucial for the proper functioning of the loft tool later. Now create the other line. Start from the center of the circle and move downwards. Place the first point at the center, then continue downwards with the line. Hover over the circle and make sure that the tangent tooltip appears on the screen before clicking. This will ensure that you achieve tangency. Now, let's move on to the next step, creating a fresh horizontal line. We'll use this point as our reference. This line will serve as the foundation for the construction you see in front of you. Alright, grab the circle tool and create a new circle down here. Make sure its center is at this point. Snap it to the point on the right and right-click to confirm. As you can observe, it is exactly half the size of the 2 main circles, which measure 9 centimeters. I want to draw your attention to another point of tangency that we can use to create the tip of the crane hook. Now let's create the second circle. Pay attention to this part. You must snap it to the extreme left side of the first circle. Then drag and snap it to this line, which represents the extreme left side of the 18 centimeter circle. And there, another point of tangency was created automatically. Notice this point here. Alright, now let's move on to creating the larger circles that will form the tip of the hook. To start, grab the circle tool once again. Click on the intersection point, which is located at the left of the first 4.5 centimeter circle. This time, you'll need to extend the circle all the way to this point right here. By performing this action, you will effectively double the size of the circle, resulting in a diameter of 9 centimeters. Now let's focus on this area where we have formed the tip of the hook. It naturally curves in this direction without any struggle, giving it a perfect and natural curvature. To complete the other half of the tip, simply create another circle. Now, click and drag it over here and snap it into place. And voila, you'll see that the desired shape has been successfully formed. We will learn how to bring the shape of the crane hook to life by cutting those circles on the points of tangency. Alright, let's examine this area closely. You'll see that there are 2 additional points of tangency. To create these points accurately, we will make use of the tangent circle tool. This tool requires 2 input points. Once you have provided these points, Plasticity will generate what is known as a tangent circle. Got it? To access the tangent circle tool, simply hold down the left mouse button here. Once you do, you'll see the tangent circle option right here. Now, let's create a tangent circle that is the same size as the one on the right side. You don't need to be precise with the measurements, just estimate it visually. Just pick the 2 curves where you want to create the tangent circle, like shown in the video. Fantastic. You can hold down the Alt key and right-click and drag your mouse while the tool is active to zoom in or out. Right-click to confirm. Alright, we'll be using the handy tangent arc tool. It's super easy to use. You'll find it right below here. First, click once to define the starting point of your arc. Make sure to click on the intersection point. Then, grab your mouse and drag it to shape the arc. If you need to flip your arc, no worries, we've got you covered. Just press the D key and watch your arc flip like magic. Once you're happy with the shape, simply right-click to confirm and voila! Your first tangent arc is complete. Now onto the next two arcs. Follow the same steps as before. Click once to define the starting point, drag your mouse to shape the arc, and right-click to confirm. Alright, as I mentioned earlier, we have 8 points of tangency. What we need to do next is cut the circles at the points of tangency. Then we can unjoin the circles and lines. Finally, we can delete the excess parts. This action will bring the hook to life. Let's do this right now. To split the circles, we'll be utilizing the Split Curve tool, conveniently located on the toolbar. But before we proceed with the splitting process, it's important to hover over the point of tangency. Keep your cursor in that position until the Snap Intersection tooltip appears on the screen. Once it does, simply click on it to split it. Here is where you'll find the Split Curve tool. To split the point of tangency, simply hover over it and click when the intersection tooltip appears. Repeat this action as many times as needed. Follow along with the video, guys. Once you've done that, press the J key to unjoin the curve and delete what you don't need, this part here. Look, this is what you should achieve. We also need to split the line at this point where another point of tangency is occurring. Now, we can get rid of the linus. I noticed a problem here. There is no smooth transition. To fix this, I will simply delete the arc, select the 2 points, and press the L key to loft them. This will restore the tangency. Take a look at it now. Alright, let's pick up the pace a little, guys. You should be able to handle this on your own now. Use the tangent circle here to create the tip. Now let's split the point of tangency that we just created using the Split Curve tool. And there you have it. That's our hook. We have multiple lines, but what I want to do is connect them using the Join tool. Simply select the curves and press the J key. It is important that the tip of the hook aligns perfectly with the curves below. To achieve this, follow these simple steps. 1. Select the 2 points at the top. 2. Press the L key. 3. Use the D key to adjust the tension to make it rounded while maintaining tangency on both points. Now, let's move on to the next phase, which involves using some lofting techniques. This is my usual approach when working in Solidwork. I create a plane to sketch my sections on, and that's exactly what I'll do here. To create a plane for sketching your cross-section, you can follow these steps. 1. Start by creating a 2-point circle. Click on a point along the curve and draw the circle in the direction of its normal. Follow the purple line. 2. Next, click on the point where the snap tooltip indicates an intersection. Now, you can start sketching your section on this circle. Make sure that the sketch touches the guides at the designated points. If you're drawing your sketch vertically, you can easily change its direction by pressing the V key. This will allow you to switch between horizontal and vertical orientations. Make sure to follow the purple line when drawing the circles. Now let me show the method I use when working in Solidwork. It's a simple yet effective approach that involves adding 2 curves and then using the Loft tool to create a surface. This allows me to sketch anything I desire with ease on the given surface. Create a line that crosses the hook. Press Shift plus D key to duplicate the line. Move the new line 2 units to the right. Then mirror it across the y-axis. Finally, select both curves and press the L key. This is the plane we will be using to sketch our sections. Alright, to effortlessly create the cross-section, switch to face selection mode by pressing the 3 key, then select the face and hit the space bar. By doing this, not only will a new construction plane be generated in line with the selected face, but the selected face will also be aligned with the camera view. This method allows you to comfortably sketch your section. Let's draw the first 2 circles. It needs to be 1.125 centimeters. But why is that? What we're specifying here is the radius. The diameter of this circle is twice the radius, right? Let's examine the circle above. If you take a closer look, you'll see that there is a precise distance of 2.250 centimeters between these 2 points. Let's create a circle from the center to the middle of the curve. This will define the middle point between the inner circle and the outer circle, which is exactly 1.125 centimeters. To ensure a seamless and smooth lofting process, it is important to give your sketch the appropriate radius. This will allow the hook with the ring to loft up here without any issues. To access the Measure tool, simply press the F key and type Measure in the command palette. Once you have the tool active, click on 2 points of the circle. You'll notice that the diameter is exactly 2.250 centimeters, just like the ring above. We're going to sweep a ring along the middle circle above, which has the same diameter as the circle below. By taking this action, you will guarantee a well-executed lofting process. Now, let's move on to creating 2 tangent lines using the Line tool. First, place the first point, then hover over the other curve until the tangent snap appears and click again. Finally, right-click to confirm. Let's move on by grabbing the Split Curve tool and clicking on the intersections to split the circles. The capsule shape is crucial as the initial cross-section because it aligns perfectly with the cut we will make above it later. However, for the remaining sections, I will take a different approach and use a different shape. After that, select the two circles and press the Alt+J key to unjoin them. Now, it's time to delete the two halves of the circles. Once that's done, use the Join tool to connect what's left. And voila, we have our first cross-section. For the remaining cross-sections, I'll give them a more trapezoidal shape. A trapezoidal cross-section hook is designed to withstand high compression on its lower portion and tension on its upper surface when subjected to a load. In real life, this is the most important thing. Now let's put the technique we just learned into action and create a new plane. We'll use it to sketch a trapezoidal shape. Create a 1 centimeter line. Next, a 1.5 centimeter line down here. Loft between the points and set them to G0. Join the three curves, select both points and bevel them. 0.5 is the value you want to use for all the section. I will create 5 cross sections, the last one being lofted with the tip of the hook. This curve must be 1.6 centimeters. To make the hook more reliable, I've chosen to extend its curve and increase its thickness in areas that experience higher levels of load. This modification will ensure that the hook can withstand greater levels of compression. Draw the first line down here. This positioning in the hook causes the plane to be upside down, right? The first line, 1 centimeter. This line, 1.3 centimeters. Let's continue with the steps we've taken before. Let's create a simple 2-point circle at this point. In order to loft the tip, let's begin by drawing a line connecting the 2 points. Next, create a perpendicular line. Then divide the curve above, detach it by pressing Alt+J key and remove this half. Now let's create a simple circle with its center positioned in the middle of this curve. Finally, we can select this object and smoothly sweep it along the circle. There it is. We'll divide the curves precisely at the point where the first plane begins. You can use the split tool. Moving on, all you need to do is press the Alt+J key combination to unjoin the curves. This action will separate the curves into multiple individual ones. Once that's done, select all of them and join them back together. By doing this, the surface will stop right at this point. Alright, it's time to start lofting. First, select the edge of the tip. Then, hold down the Shift key and pick all the other sections. If the Extend tool activates automatically, just right-click before pressing the L key to loft. Finally, press the L key, and voila! We have our first lofted surface. Before confirming, hold down the Shift key again and select the two guides as well. As you can see, there are no errors occurring. Let's start by creating a curve that goes from the center to the right-hand side of the circle. Once that's done, we can cut the curve in the middle and remove the left side. Now, it's time to create another circle. This one will start from the center and go to the middle of the curve, resulting in a circle in between the two ones. Place a circle right in the middle of it. This will serve as our profile, which we will sweep around the circle to create a ring. It's important to note that the diameter of the ring should match the section below it, ensuring a seamless connection between the ring and the hook below. As you can see, the edge down here is fragmented, which can lead to lofting errors. To address this issue, here's what I'm going to do. First, I'll select the entire edge and then extend the sheet up to this point. Next, I'll create a spline and snap the points on the intersection. Once the curve is created, I'll extend it a bit using the Extend Curve command. This will ensure that the solid is cut properly. Now, select the spline and press the C key. After that, select the hook and right-click to confirm. Delete the top part. Alright, now the cut we make on the ring to connect the hook to the nut will determine whether the loft tool will work or not, so it's crucial to get it right. To achieve the desired cut, we will create a shape consisting of two tangent circles. To ensure precision, I will use the spline and the circle located in the center of the ring as reference points for the tangent circle tool. By doing so, I can accurately snap the tangent circle onto the points of tangency. Let's create another one on the left side. This is the shape we're looking for. To start, select all the circles and splines. Isolate them and then use the split curve tool to divide them. Next, unjoin them by pressing the Alt plus J key. Now, delete these curves and voila. Now we have the ideal form to slice through the solid ring. Now, choose the shape we just created. Press the C key, then select the ring. Next, press the right mouse button to confirm your selection. Now, let's delete the faces underneath the ring. To do that, press the F key to open the command palette and search for the Delete Face command. Once you've found it, execute the command. This step will prepare you for the next action, which is lofting between the ring and the hook. The curve above is more complex than the one below, which can lead to errors. To avoid this, we will provide a few guides to help Plasticity loft these two edges. First, activate your ISO param tool by pressing the Ctrl R key. Next, create two new loops. To switch between horizontal and vertical modes, press the Tab key. Then snap the cursor to the desired location and left-click to create the new loop. Finally, right-click to confirm. Repeat the same process on the other side. Now select the new edges and press Shift plus D to generate curves. After that, select the points and press the L key to loft them. By following these steps, Plasticity will be able to determine the correct direction for our sheet to go. Now first, select the above edge, then hold down the Shift key and select the other edge. After that, simply press the L key. Next, hold down the Shift key once again and choose the guides one by one. And voila! Take a look at this, folks. The sheet underneath seamlessly blends into the ring above. Fantastic work, everyone. Let's now select the sheets and press the J key to join them. Next, let's move on to creating the spring latch and the latch itself. To accomplish this, we will utilize a straightforward Boolean operation. Assuming you've already watched my previous 6 videos on plasticity for beginners, I won't go over the basics of using the most common tool again. Sound good? To confirm, simply press the right mouse button. Next, select the cylinder and press the Q key. Now, choose the hook. You'll notice that the Boolean tool is now active. Feel free to move the cylinder to any desired location and select the appropriate spot. Select the edges all at once. I will apply a G2 fillet to them. Next, create a little circle. Here, press the CU key, select the hook and right mouse button to confirm the cut. Now delete the cut part. At this stage, you might want to mirror the hook. Don't forget to click on Merge Halves Together option in the Mirror tool. Let's bevel this out. In the next step, we will create the spring latch. To achieve this, you can use the spiral tool. First, click on the tool. Then click once on the center of the hole and drag your mouse to define a spiral. As you can see, we are unable to create the spiral directly. Therefore, we need to first create a circle to which we can snap the spiral onto. Now, let's adjust it. We need to set a proper radius and the number of spirals. I would recommend setting the number of spirals to 2. Next, we need to rotate the spiral so that the tail and the head point downwards. You can also cut the tips if necessary. After that, choose the line tool and create the curve as shown in the video. Now you can mirror the spring. Join both curves by pressing J key. No need to do this, guys. I'm pausing the video for a moment to delve deeper into the concept of tangency. If you're not interested in the theory, feel free to skip ahead. I am not going to stress you guys with formulas, equations, and stuff like that, I promise. So what exactly is a point of tangency? Well, imagine you have a curve like a circle or a parabola and a line that intersects it. The point where the line touches the curve without crossing it is called the point of tangency. It's like a gentle kiss between the line and the curve, where they meet briefly and then continue on their separate paths. Now, let's bring this concept to life with a concrete example. Imagine you're riding a bicycle and you come across a curved road. As you navigate the curve, your bicycle tire touches the road at a single point. That point of contact is the point of tangency. It's the moment when your tire and the road connect, allowing you to smoothly maneuver through the curve. Points of tangency are not only found in the physical world but also in mathematics. They play a crucial role in geometry, calculus, and other branches of mathematics. They help us understand the relationship between curves and lines and how they interact with each other. To further illustrate this concept, let's consider a parabola and a tangent line. A parabola is a U-shaped curve, and a tangent line is a line that touches the curve at a single point. This point of tangency is where the line and the curve share a special connection. It's like they're dancing together, perfectly aligned in their embrace. Understanding points of tangency is essential in various fields, such as engineering, architecture, and physics. They allow us to design smooth curves, calculate rates of change, and analyze the behavior of objects in motion. In summary, points of tangency are the magical points where curves and lines meet. They are like fleeting moments of connection where two entities come together and then continue on their separate paths. Whether in the physical world or in mathematics, points of tangency play a significant role in understanding the relationship between curves and lines. Okay guys, let's start off where we left. As I mentioned before, I'll start by sketching the profile of the latch using the line tool. Once that's done, I'll extrude the blue region to give it a solid shape. Then, I'll add some bevels to certain edges to enhance its appearance. Finally, I'll select specific faces to hollow out the solid, giving the latch a more realistic look and feel. This step-by-step process will bring the latch to life. I'll extrude the region to create a solid shape. Once that's done, I'll select the faces underneath and use the hollow solid command to hollow out the latch. This will bring the latch to life. Alright, put it in the middle of the scene. We're going to mirror it in a bit. So, let's give the pipe tool a try to create the spring. However, there's a chance that the pipe tool might give an error because the curve hasn't been rebuilt yet, just as I had imagined. To fix this, you can take the curve and rebuild it. The Rebuild command can be found down here in the toolbar. Click on the Points option and set the number of points to something like 120. Then click OK. Now, let's try the pipe tool again. And there it is. Look at that, a nice spring. Now let's mirror the latch. Alright, we've made it to the end, folks. Now let's move on to the final step, creating the pin that will hold everything together. It's actually a pretty straightforward process. First, I'll perform the Boolean operation, and then I'll create a simple cylinder that will serve as the pin. Finally, let's fillet the latch and you're all set. With those faces selected, press Ctrl+2 to convert the selection into edged selection. Our crane hook is finally finished. Now, let me show you the hook with the rough and bump map applied. Alright guys, that wraps up this episode. I can confidently say that your skills have definitely leveled up after watching this video. I really hope you enjoyed it, and I would be thrilled if you could subscribe to my channel. Don't forget to hit the bell button to stay updated on new videos like this. I'll catch you in the next one.